Modern software architectures often consist of containers that run services. Those containers scale up and down depending on the demand for those services. These large software systems also often use a technique known as event sourcing, where every change to the system's data model is kept in an event log. When an event on the log is processed, several different data stores might be updated in response. In these architectures, containers are often interacting with each other. Multiple databases are responding to events in the event log. To connect these systems together, engineers can write small functions to pass data around. You might call these small connecting functions glue. Glue functions are a great use for a serverless tool such as AWS Lambda or Google Cloud Functions. As these glue functions grow in popularity, there's an increased need for an open source way to deploy serverless functions, or otherwise known as functions as a service. And by the way, I know I'm talking about a lot of things that are some advanced concepts here. If you're not familiar with serverless or microservices or Kubernetes or event sourcing, we've done shows on all of these topics, and feel free to turn off here and go check out our back catalog for these other subjects. Sebastien Goasgoen works on CubeLists, a serverless execution tool built on top of Kubernetes. In this episode, we explore his take on the serverless on Kubernetes problem. This is a great companion episode to yesterday's interview with Soam Vasani about his tool, Fission. Software Engineering Daily is looking for sponsors for Q3. If your company has a product or service, or if you're hiring, Software Engineering Daily reaches 23,000 developers that are listening daily. So send me an email, jeff@softwareengineeringdaily.com, and I'd be happy to talk to you about sponsorship. With that, let's get to this episode, Event-Driven Serverless with Sebastien Goasgoen. Blockchains are a fundamental breakthrough in computer science, and Consensus Academy is the place to learn about blockchains. The Consensus Academy Developer Program is a free, highly selective, and carefully designed 10-week online curriculum where you will immerse yourself in blockchain development and earn a Consensus blockchain certification. By completing the program, you will be eligible for immediate hire by Consensus, a leader in the blockchain space, focused on the Ethereum platform. If you want to learn about blockchains and become a developer for blockchain technology, check out the Consensus Academy by going to softwareengineeringdaily.com/blockchain. The graduation ceremony is a spectacular, all-expenses-paid trip to Dubai, where you will meet blockchain developers working on real-world solutions. Dubai has announced ambitious plans to become the first city to run on blockchains by 2020. If you like the idea of immersing yourself in blockchain technology, graduating, and going to Dubai, check out softwareengineeringdaily.com/blockchain. Build your new career on the blockchain with the Consensus Academy Developer Program. Applications are open from now until July 1st, so you want to apply soon. For more details and to apply now, go to softwareengineeringdaily.com/blockchain. To learn more about Consensus and Ethereum, please visit consensus.net. That's CONSENSYS.net. And sign up for the Consensus Weekly newsletter for everything you need to know about the blockchain space. Thanks to Consensus for being a sponsor of Software Engineering Daily. Sebastien Goasgoen works at Bitnami, and he is the creator of CubeLists. Sebastien, welcome to Software Engineering Daily.
Yeah, thank you, Jeff.
You have written some books about Docker and Cloud Stack, and you've been somebody who's worked on cluster computing for a long time. So let's start with a little bit of history. Can you give me some perspective on your evolution as an engineer in the cluster computing area?
Yeah, definitely. That's an interesting question. I'm gonna try to be relatively brief. But I've been around a little bit now, so I've seen several things in the industry. I spent a lot of time in academia. I enjoyed research. So interestingly, I'm actually an electronics engineer. I worked a lot on things like radars and antennas and things like this. So nothing to do actually with computer science, or not directly related. But very quickly, I got into computational science. So now we're talking supercomputers, clusters of servers, and the need to orchestrate all those servers to be able to do computation and solve very interesting problems. So naturally, I went away from my natural tendencies of, electronics, nanotechnology, things like this, and I got interested in making computing a utility. So really, cloud computing. How can we, harness all the power of clusters and bring that to people in a very easy manner?
It's been interesting to watch the adoption of industry adopting all these distributed systems and things that used to be widely discussed in the theoretical computer science community, bringing these to implementation. Can you comment on how you have seen the differences between academia and industry evolve? And it's just, from my point of view, it seems like they've basically converged.
Yeah, that's actually a very good point, and that's why I left academia and I joined the industry. Wanted to be more on the industry side. So cluster computing, supercomputers is still going strong in academia. You got lots of supercomputer projects in the US, in Europe. You got things that are being driven by CERN, obviously, but you got all the supercomputer in the US. I was very involved in this, and some of the problems was definitely scheduling, efficiency of using those clusters. Some problems were also around, security, running code from anonymous people, potentially running malicious code and things like this. So those experiences and areas of research led to the use of virtual machines in grids, virtual machines in clouds, in supercomputers. Also, of course, also the use of containers for better scheduling, better packing of workload on computers. So all those themes of, efficient scheduling, improved efficiency of the clusters, that's exactly what you find with things like Kubernetes, which is about, orchestrating containers, but with an idea towards, greater efficiency, packing more workloads on the server. It was also the same theme with, virtual machines when VMware, came out with all their solutions, which was about consolidation of servers. So definitely you see the same themes over there.
Mm-hmm. We've done a lot of shows on Kubernetes. We've done a lot of shows about serverless as well. And I'm sure we're going to do a lot more on these. For people who are a little unfamiliar with these topics, but maybe they've heard one or two shows, give the audience a quick refresher on what Kubernetes is, what serverless is, why these two technologies are important.
Sure. Yeah, so Kubernetes is I would say the next evolution in a way to manage your workloads. So, there were solutions like OpenStack and CloudStack, which were virtual machine driven. They were very much about, deploying your workloads on VMs, which would be, an Onprem cloud solution. And now there is this evolution thanks to Docker of actually using containers as a packaging format for the workload. And also, it's pushing towards, breaking up monolithic application and embracing more of a microservice applications. application mindset. So as you go towards containers, now you need a system to be able to manage all those microservices instead of more bigger VMs. And Kubernetes is quickly becoming the de facto almost standard to really orchestrate those containers at scale. But it's not only an issue of scale, it's also an issue of, what are the APIs that you can use with Kubernetes to basically architect your application, handle fault tolerance, handle configuration, and so on. So you got Kubernetes on one side, and I'm sure, the people listening have heard your shows already on Kubernetes. One thing that's interesting with Kubernetes is that it also allows you to build extremely new and exciting system. And you could call them PaaS, platform as a service solutions. So those PaaS-like solutions are extremely easy to do on top of Kubernetes. So now you have all of us that have been working on infrastructure for a long time, on trying to make computing a utility, trying to make infrastructure boring. Now we actually start going back towards things like PaaS, trying to actually concentrate on the application again, going back to the applications. And now we figure out that things like serverless, are much more interesting and powerful. So that we go back to, actually concentrating on the logic that you have in your application. You concentrate on writing the little bits of logic that are critical to your system. And you want to figure out how to deploy those little, logical items. So serverless is very much about, going back to the roots of your application logic, concentrating on, those logical, units. And deploying them as quickly as possible, and building much more interesting distributed applications.
The way I have started to think about Kubernetes, like you said, it's a tool where you can easily build PaaS on top of it. Ruby on Rails, the common way that people would explain Ruby on Rails is you can build Twitter in a day. You can build an application that makes a Twitter. Like the entire functionality of Twitter in a day on Ruby on Rails. And with Kubernetes, you might be able to say the same for Heroku. You could build a Heroku in a day, an entire full-fledged platform as a service on top of Kubernetes in a day. And that's what's so impressive about it. And that's why we've seen such massive adoption. Like the adoption of Kubernetes is, I think it's more aggressive than any other open source technology in history. Maybe it's outstripped by Linux, but in terms of production use, Kubernetes is widespread. We've done shows with Meetup and several other companies who are deploying production Kubernetes clusters. Mm-hmm. Serverless, on the other hand, assuming we're talking about functions as a service, this idea where you write your code, you write some blob of code, and it executes against a serverless cluster, which is there's some resource that gets spun up and it executes that code, and then that transient resource just disappears somewhere or it gets cached for a while or something. That is a technology that a lot of people are talking about, but I have seen less production adoption of, except for things like image resizing or really well-defined atomic operations where you can very easily have this disposable container. So I've heard you talk about this. You encourage people to not dismiss serverless just because there is a lot of buzz and a lot of hype around it, and perhaps there's not as much production use case quite yet. So remind listeners what is the value of serverless, despite the fact that we're not seeing a whole lot of production use of it today.
Yeah. So, first, I'd like to go back to Kubernetes and it being, easy to write like a PaaS-like system. it's extremely easy to write a POC, a proof of concept. But really a full-fledged, pass, it's going to be a little bit more, complicated. But I totally agree that, all the primitives are there in Kubernetes to be able to build those systems. So now, production, and it's something in our industry, we tend to say, oh yeah, I'm production. And we're never quite sure what people mean by I'm production. So I want to be, always careful when we say we're production, because people, see it in a different way. But definitely, talking about adoption, starting with Docker was adopted extremely quickly. The pace of adoption of Docker was extremely quick. And I think it was quick because developer really embraced it. So the developer really saw the strength of Docker to be able to, quickly get a Redis or get a MySQL, get a Memcache, running on their laptop for development. But then once people, indeed started focusing on production, they understood that they needed to move towards a real cluster. They needed, a networking solution. They needed an orchestrator across machines and so on. And that's why, there was a little bit of a lag between the adoption of Docker and then the adoption of Kubernetes. Even though Kubernetes, of course, arrived after Docker. But now what we're seeing, and I agree with you, is that Kubernetes is definitely catching up, and the adoption, of Kubernetes is quite impressive. Even out of Europe, which is, very, I would say traditional, or they're very skeptical about new technologies, especially technologies that come out of Silicon Valley. But even in Europe, you see adoption of Kubernetes, picking up extremely quickly. Now, back to serverless and your question. Sorry, I went around here. So back to serverless, you do see people in production like iRobotics and so on. And even in Europe, you have, people adopting, serverless in production, or which I should say, AWS Lambda in production. Because if you look at solutions to do serverless, right now it's, Lambda on AWS, Google Cloud Function, is starting, but is still behind, what AWS can do. You got Azure Functions, but again, AWS is still in the lead. So when we look at production, we actually have to look at AWS Lambda users. The key for these guys is that they are already in the cloud and they're using the cloud services of AWS. So they're using the S3 store, they're using the messaging system, they're using, maybe like a Vision API or EC2 or whatnot. So they're using existing services. And now they're trying to tie all those services together into an actual more complete application. So they're becoming, what Patrick Desbois from the DevOps movement called service-full. So instead of serverless, he mentioned, in fact, people are going service-full. So they're just writing little bits of logic to link the services. So the key for serverless is going to be a framework that allows us to write those little functions and deploy them, and whatever that means underneath. But it also means that we're going to need services, so cloud services, available to tie them together. And the real key is going to, indeed have those services and have those services emit events that can trigger functions. So we're, people are in production. Yes, you have a few already. But it's still, very, very early. And that's why at Bitnami we're pushing CubeLists. It's still very early, very much a exploratory learning phase. And, I think we can, meet again in maybe 2 years and then we'll be talking about real production.
Do you want the flexibility of a non-relational key value store together with the query capabilities of SQL? Take a look at CTreeAce by Faircom. CTreeAce is a non-relational key value store that offers ACID transactions complemented by a full SQL engine. C-Tree-Ace offers simultaneous access to the data through non-relational and relational APIs. Companies use C-Tree-Ace to process ACID transactions through non-relational APIs for extreme performance while using the SQL APIs to connect third-party apps or query the data for reports or business intelligence. C-Tree-Ace is platform and hardware agnostic, and it's capable of being embedded, deployed on premises, or in the cloud. Faircom has been around for decades, powering applications that most people use daily. Whether you are listening to NPR, shipping a package through UPS, paying for gas at the pump, or swiping your Visa card in Europe, Faircom is powering you through your day. Software Engineering Daily listeners can download an evaluation version of C-Tree-Ace for free by going to softwareengineeringdaily.com/Faircom. Thanks to Faircom C-Tree-Ace for being a new sponsor of Software Engineering Daily, and you can go to softwareengineeringdaily.com/Faircom to check it out and support the show. The architecture that you're describing is people are building applications with things like S3 and Firebase and maybe Heroku and maybe Amazon Kinesis, which is like an event queue, and maybe DynamoDB, which is a really rich database. And you want to use these managed services because they take a lot of the frustrations of running your own database. Like, nobody wants to run their own database anymore and be responsible for the uptime of the database. You'd much rather have AWS assuming you're cost insensitive, you would much rather just have it hosted and have AWS be responsible for it. But of course, you need a way to have these services interact with each other, and so that's why we still are managing servers somewhat. We have servers that have lines of code that say when this S3 bucket gets changed, do this other thing over here, and you've got to do glue code between S3 and some other service that you're using. But serverless, in terms of AWS Lambda or Google Cloud Functions, it's extremely cheap. I mean, these functions are really cheap to run. What's the motivation for wanting to have a homegrown serverless on top of Kubernetes platform if it's so cheap to use these hosted services?
Yeah, that's a very good question. And there's been lots of talks about everybody going public cloud and then are people going hybrid cloud and so on. And I don't really like to be caught up on definitions, what hybrid cloud means or what serverless means and so on. But definitely what you're going to see is much more of a gray world where, as you say, some enterprise are going to say, hey, that bit of service, I actually much prefer having Google or AWS manage that service and use their DynamoDB or use their Cloud SQL, whatever. So people are going to study their infrastructure and they're basically going to outsource some components to the cloud. But then that means that they're going to have some type of hybrid environment, so they're still going to have some on-prem and then some cloud services. But those bits of a glue code, exactly as you mentioned, you're going to need to be able to use some glue code deployed in the cloud and then some glue code deployed on-prem. So, as soon as you start looking at containers for some of your applications that are on-prem and that you start deploying solutions like Kubernetes to manage those containers, it makes total sense to be able to, have a serverless, a FaaS solution on-prem. And that's exactly what we're doing with CubeLists. We're saying, hey, you're going to embrace Kubernetes on-prem for your new containerized workload. And by the way, if you deploy Kubeless, then you'll be able to use FaaS. Okay, and the CLI that we provide is compatible with Google Cloud Functions, so it's exactly the same thing. And then, we also provide a plugin for the serverless framework. So if you're on AWS using Lambda and you're now familiar with the serverless framework, you can also use CubeLists. So, I think there's definitely room for a hybrid, type and environment, and CubeLists there, makes total sense.
There are people listening who might right now be like, well, but who cares about on-prem? If we're talking about on-prem, we're just talking about banks and old healthcare companies and these companies that they don't actually need to be on-prem. They're just slow to the game. But the reality is that there is going to be an increased uptake in more on-prem companies. For example, I talked to someone from the Microsoft Azure IoT team, and he was talking about Azure Stack, which is a on-prem deployment of Azure technologies. And it's like, okay, why would you want to do that? And the example that we talked about is if you've got a factory, let's say you've got a factory, and this factory has cameras all throughout the factory, and you want to have machine learning models that are processing the data from those video cameras really quickly and making judgments in real time, quote unquote real time, whatever that means, but just low latency essentially. And you want to be able to identify there's been a chemical spill and we should close off this area or warn everybody to avoid this area. If you want to get the latency really low, you actually probably want to do something on-prem. And if you want to have this similar model to what you have in the cloud in your on-prem systems, then you might want to have a serverless architecture for writing the glue code for your big, bulky on-prem system.
Yeah, and the reality is companies like Oracle and even Red Hat to some extent, which does most of its business for the enterprise, which you can consider on-prem. Cisco, VMware. I mean, all these big companies still have a very healthy business. So there is a move towards public cloud, definitely with Google at AWS, Microsoft, but the end of the enterprise infrastructure and on-prem, is not near. So it may be in the future, but it's going to be a long time before this is the case. And now when you talk about the cloud and everybody is going to the cloud and it's people are late to the party, when you talk to people who maybe not at the forefront of things, they still have a ton of legacy. They're still struggling with embracing, some even version control, embracing configuration management. A lot of the things that we do in our industry when we say, oh yes, DevOps and config management and Git and so on, there's still a lot of people that are way behind. That are dealing with, lots of Java application that they need to run without configuration management and so on. So it's a little bit of a long-winded, story, but I think we have to be aware that there is definitely a huge market and a lot of people that are still in the enterprise, as we say, and not going to the cloud, anytime soon.
Companies like Google. So let's take Google as an example. Google has the Google Borg, and this is the project that Kubernetes was based on. And this is what most Googlers still use internally to run their services. It's a cluster manager where you can deploy your application against this giant cluster manager that manages all the resources at Google. Do you know if they have an internal serverless technology for writing their glue functions? I mean, or Amazon perhaps. These companies that are at the forefront of cloud management, are they actually using these types of services internally to improve their server usage?
It's a very good question, and actually I never asked them. So I actually don't know if they have, basically an internal Lambda, type function. I think it makes total sense, and they probably have. Definitely I know for a fact that, in the case of Borg, different groups within Google have developed their own, domain-specific language to describe application, and then they've written lots of different types of wrapper on top of Borg to deploy application and even manage them in a certain way. So I wouldn't be surprised if some of those PaaS-like solution are actually very close to what we call now a FaaS solution. And again, sometimes we tend to get really caught up in naming. For me, the issue, or what we're trying to do with serverless, is really even, forget about Kubernetes, forget about containers. Let's go back to the application. Let's go back to the code. You got some bits of codes on your computer. How do you run that in a distributed manner on remote resources? It's almost a theoretical question, but it's very basic, Forget about the how it's being done. Indeed, forget about the servers, but forget about Kubernetes and forget about containers. You don't need to worry about Docker, but you care about your code. You care about debugging your code. You care about your code being able to serve all the requests that it needs to, and you care about your code being triggered properly and so on. So how do you make that happen? How do you make that happen extremely quickly, so that you can innovate quickly and so on? So I'm sure that internally, Google has, probably several different systems to do this, and AWS as well.
Yeah, now they could just use Google Cloud Functions or AWS Lambda internally if they want to.
Or CubeLists. I'm sure they're going to
or CubeLists.
CubeLists internally.
Or CubeLists, or one of the other serverless on Kubernetes implementations. So let's talk about CubeLists itself. I think at this point we've motivated the serverless on Kubernetes discussion. And I think, I like having these discussions over and over and over again. We've rehashed so many of these topics about architecture on different episodes, but I think it's really useful because this is a lot of where things are going. And I think it's really useful for people to just get refreshers over and over again on how these things work and why they're important. But now that we've done that, let's get an overview for the CubeLists architecture.
Yeah. And you're totally right with rehashing those ideas, and that's very much what I keep in mind all the time. A lot of the things we do, they're just evolution. They're not new. It's just, we progress, things evolve, we have new technologies coming in, but we're still trying to do the same thing, which is, run your code. The time from development to production of your code should be extremely quick, so it's like a mean time to production, MTP or something like that. That should be extremely quick. So CubeLists, the idea was really that Kubernetes gives us all the primitives to be able to build a very exciting and useful system. The Kubernetes API is extremely powerful. That's one of the reasons why I jumped on Kubernetes. The pod concept, the deployment concepts, which allows you to do rolling updates, rollbacks, the service concept for routing your traffic properly to the right containers. There are lots of different API primitives in Kubernetes that are extremely powerful. So when you think about writing a system to do something like serverless, you can leverage all the strength of Kubernetes. And that's why we call CubeLists Kubernetes native. What we're trying to do is write actually a very minimalistic system. So it's not going to take us just a day. It's going to take a while, but it's as minimalistic as possible because we reuse all the Kubernetes primitive. We reuse deployment, we reuse services, and we reuse especially the third-party resource to extend the Kubernetes API. So that was the main idea behind the architecture. So now in details, Kubernetes has this concept of third-party resource, which is a way to extend the Kubernetes API. It's extremely powerful. It means, you're trying to build a new API for your application. You can actually use the Kubernetes API server itself by writing your new API resources, giving it a spec, and then, Kubernetes suddenly is able to manage that new REST API endpoint. So it's an extremely powerful concept. We're using it in CubeLists. Things like the etcd operator by CoreOS, they're also using third-party resources. There is a new mechanism to do similar things that's coming up in the new version of Kubernetes, which is API server aggregation. So it's going to allow you to do similar type of things. But that's the first thing. We use third-party resource, and then we reuse as many of the primitives as possible.
So let me stop you there, because this is one thing we don't go into enough on Software Engineering Daily is the deep internals of systems. Sometimes we just don't go deep enough. And you mentioned this third-party resource abstraction. And as a person, I'm just a reporter on software, and I don't actually use these things, so I don't have firsthand experience with third-party resource. What does that abstraction do within Kubernetes?
Yeah, so the main motivation, we call them TPR, third-party resource. The main motivation was to say that, at one point, the core of the Kubernetes API is going to be stable. And if we've done our job, or the group that's developing the Kubernetes API, if they've done their job properly, that core should be extremely stable and shouldn't need to be expanded. So there shouldn't be any discussion about, hey, we need this new API resource, we need this new thing, and then we need this new thing, and should it get into core? And oh no, it shouldn't get into core. So there are lots of those debates in open source communities sometimes. Here, the idea was to remove that potential for debate by saying we're going to have a very strong core, stable, and then if you want to extend the API, you're going to write your API extension using this system, which is called a third-party resource. So what it is exactly, it's another Kubernetes API primitive. You write a manifest to define a third-party resource. And then what Kubernetes does when you create that third-party resource, Kubernetes now creates on the fly a new REST endpoint. Okay, so suddenly you start talking to the Kubernetes API server, and there is a brand new API endpoint that's available. Okay, and you can do HTTP GET and POST and so on. So, and now maybe we're getting into too many details, but I do think it's important.
Yeah.
So, once you've done that, you haven't done much actually. Okay. You've just, let Kubernetes create that new endpoint. What you need to do is write a controller. So you need to write some piece of code, that now is going to monitor this new endpoint. And when things happen in this new endpoint, then you're going to do some actions. So for us with CubeLists, what it means is that we create a new endpoint, which we call, function.io. Okay. So now we have a new endpoint that's managed by the Kubernetes API server, which manages functions. And the CubeLists controller just watches all the time that endpoint. And when you create a function, it says, a function was created. Let me spin up a container using the Kubernetes resources. I spin up a container and I inject the code, that glue code. I inject that glue code inside that container. And now suddenly your function is exposed. Okay? So that's what CubeLists is. It's a definition of a third-party resource to extend the Kubernetes API, and then a function controller. So we called it the CubeLists controller to be able to launch the containers and inject the function code into them.
For more than 30 years, DNS has been one of the fundamental protocols of the internet. Yet, despite its accepted importance, it has never quite gotten the due that it deserves. But today's dynamic applications, hybrid clouds, and volatile internet demand that you rethink the strategic value and importance of your DNS choices. Oracle Dyne provides DNS that is as dynamic and intelligent as your applications. Dyne DNS gets your users to the right cloud service, the right CDN, or the right data center, using intelligent response to steer traffic based on business policies, as well as real-time internet conditions, like the security and the performance of the network path. Dyne maps all internet pathways every 24 seconds via more than 500 million trace routes. This is the equivalent of 7 light years of distance, or 1.7 billion times around the circumference of the Earth. With over 10 years of experience supporting the likes of Netflix, Twitter, Zappos, Etsy, and Salesforce, Dyne can scale to meet the demand of the largest web applications. Get started with a free 30-day trial for your application by going to dyne.com/sedaily. That's dyn.com/sedaily. After the free trial, Dyne's developer plans start at just $7 a month for world-class DNS. Rethink DNS. Go to dyne.com/sedaily to learn more and get your free trial of Dyne DNS. If my application writers, what if they're just writing tons and tons of functions as a service against my CubeLists cluster? What's going on there? Is it the controller that gets hammered with all those requests and the controller scales up, or does the third-party resource scale up? I'm trying to understand the purpose of the third-party resource abstraction versus the controller abstraction that's watching the third-party resource.
So what happens for us with, from a CubeLists standpoint is that we didn't have to write our own API server. Okay, we're not writing our own API server. We're not writing our own scheduler. We're letting Kubernetes itself handle that. So when all your developers start creating function, they hit the Kubernetes API server. And it's the responsibility of the Kubernetes API server to be able to handle all those requests properly. And if you hit any limitations, you hit the limitations of Kubernetes itself. Okay? And we know how well Kubernetes is scaling now, so we are very confident that, the scale is there. And now all the storage, like the functions, where are they stored? They're stored in the etcd key value store used by Kubernetes itself. So we don't have to set up a separate database. We don't have to handle the state on ourselves. We basically, CubeLists delegates all of this to Kubernetes. Okay. And that means that we just have the controller, and the controller is just like, watching the resources and then performing actions.
So can you give me a little more clarity on what the purpose? So I understand the third-party resource is this way of extending Kubernetes to do your domain-specific things. I would just love to know in a little more detail just what is the importance of the third-party resource here? Because I'm hearing you say, okay, you set up a controller through the third-party resource or using the third-party resource. I'm just trying to understand what the purpose of the third-party resource is relative to that controller.
So if you compare with Fission, which is another serverless solution that runs, on Kubernetes, when you deploy Fission, you deploy its own Fission API server, and the developers, they're going to talk to the Fission API. Okay? The difference with CubeLists is that you're going to talk to the Kubernetes API itself, which with CubeLists will know what a function is. Okay? So that's one of the biggest difference. And then once your function is created, we use Kubernetes to actually decide where that function is going to run, in the cluster. We use the Kubernetes scheduler. Whereas in Fission, they have their own scheduler on top of it. And that's
Right.
why we call it Kubernetes native.
So in the Fission world, they have a pool of containers, a resource pool of containers that just sits around. And if you've got, like, let's say you've written an image resizing function in JavaScript, they have a pool of containers that are suited to running JavaScript. And when they get when the cluster gets a request for the image resizing, they schedule one of those containers against that function. And you're saying the difference between that and CubeLists is that in CubeLists, you've got the function, whatever language it's written in, is in etcd, and when you get a request for that function, the entire scheduling of the container being allocated and the code being loaded into it, all of that's handled by Kubernetes on the fly. Is that accurate?
Yes, that's accurate. And so what happens, the reason why the Fission guys, and I know them quite a bit, the reason why they created a pool of containers is to reduce the startup time of the function, because it's very important in serverless. So if your containers are already running and you just inject the little bit of code, the startup time is extremely short. So the latency from the time that you create the function to the time that you can actually call the function is extremely short. So for us in Kubeless, this startup time right now is longer. Indeed, it's longer because we have to start the containers. There is the scheduling time from Kubernetes, and then you have to start the containers. But we opted to delay the optimization on the startup time to actually concentrate on the functionality. So, we have the plugin, with the serverless framework. We have the compatibility with the Google Cloud Functions. We handle dependencies. And then we basically go through all the AWS Lambda examples. You mentioned image resizing and then kinesis stream and things like this. So we are methodically going through all those examples that AWS Lambda showcases, and we're trying to, hammer them out and enable that functionality. So if you go to the Kubeless GitHub repo, you'll see a short screencast of an image resizer using the Minio object store and then using Kubeless with a 50 line of Python.
With databases, we have gotten to this point where there's so many different databases based on whatever model of consistency you need, whatever model of availability you need. Do you need ACID transactionality? Do you need high throughput? And it almost sounds like if we're moving to a world where you've got most of your glue code managed by quote unquote serverless, some of those glue code operations are more latency sensitive than others. Is this a rich enough gradient that we're going to see a real variety of scheduling tools for serverless functionality?
So I'm not a database expert. I'm more of a cluster computing guy.
Sure. Just to be clear, the analogy I was trying to draw was that there's a lot of richness in, originally it was like, okay, we'll just put everything in a SQL database, but then we realized, okay, there's all these trade-offs we can have.
Yep.
And here between Kubeless and Fission, I see essentially the trade-off that you have is the cold start problem and how aggressively you're solving the cold start problem. Fission solves the cold start problem really aggressively by essentially preloading containers with some information, and that makes the latency less sensitive. And then with Kubeless, you're saying, well, we want to have these very, if we're going to solve cold start problems, then we want to solve them with individual solutions for individual problems, like image resizing or whatever it is.
No, that's not exactly what I was going at.
Okay.
We want to concentrate on enabling the application use cases, because that's what Bitnami does. Bitnami has been doing application packaging and delivery for a long time. So we concentrate on the apps. So we want to enable the different application scenarios that people are interested to solve using serverless. Okay. So we're going through all those application scenarios: data processing, data streaming, image resizing, mobile backend. So we're going through all those different scenarios and figuring out, what do we need to build into CubeLists to enable those scenarios for the apps. And now, our thinking is that the startup time, since we are Kubernetes native, we actually offload the problem of the startup time to Kubernetes. And what we want to do is basically say, okay, now we can do Kinesis stream, but let's say there is a problem with the startup time. So now we actually go back to Kubernetes upstream to the project, and we say, hey, when we are scheduling this in such and such conditions, the scheduler is really bad. Can we do something? And now we can actually write a serverless optimized Kubernetes scheduler because it's, we can tune that. But basically, we feed those requirements back to the Kubernetes community to make sure that Kubernetes can actually handle that. Okay. So that's our entire, philosophy around developing CubeLists. Now, the one big thing also that's different with Fission and we haven't talked about it, at all, but it, even for serverless in general, it's very important, is events. So all of this is only useful if the services that we try to glue together emit events. And right now there's lots of debates about, coming up with some standard around events, around interfaces to events and things like this. That's going to be a big challenge for the serverless community. But the one thing we did with CubeLists early on is that we wanted to enable events. So when you install CubeLists, you also get a Kafka broker, which is deployed inside Kubernetes. It's a standard Kubernetes stateful set, Kafka and Zookeeper deployment. And that means that now any of your services that emit events, if they can emit those events into Kafka, your functions can be triggered by events, which is a totally different scenario than triggering via HTTP. Okay. So we get that out of the box. And it plays an interesting role with what you're saying about databases, because there are lots of scenarios, people are talking to us and they're saying, well, actually my transaction in my database, I would like, all my database events to go into a Kafka broker. So what we're working on is actually figuring out a way to, ingest all those events from databases and other things into our Kafka setup in CubeLists so that they can be triggered by a function. So now you make an insert in MySQL and that triggers a 50 line of code, Python function.
Okay, that's actually really interesting. We did a show with Neha Narkadeh from Confluent a while ago, and she was part of the founding team of Kafka, and we talked about event sourcing. We talked about event sourcing on Kafka, event sourcing or CQRS. I'm not exactly sure which one is referred to specifically, but basically the idea is every time there is a change to anything across your application's data, you put that in a Kafka queue or some kind of queue, and you have different consumers of that data change. So if you have a change to a user's profile, you're going to need to update several different databases. You need to update the user database. Like if a user goes onto their profile page on Facebook and makes a change to their user profile, you're going to need to change the user database. You're also going to need to change the Elasticsearch cluster that powers the search over all of your users and all of your other data. Maybe you need to change some other databases. And so the question is, okay, if we want to be able to trigger multiple database changes based off of one user operation, how do we do that? And the answer is you put the event on a queue and you have listeners that are somehow wired to listen for that type of event, and then those listeners process that event and make the change to the respective databases that need to get changed. And this takes a lot of resources because you've got tons of database changes incoming. And basically what you're saying is this is a perfect application for serverless because you've got all these quick database changes that need to be made, and it's kind of an atomic event, and you probably want customized ways of making each of these changes. Am I describing the situation accurately?
Yeah, no, perfect. A big thing for serverless is event-driven based application. In itself, it's not new. It's, you bring enterprise service bus, type application, and you have similar things. The key here is that those complex scenarios which need a fairly complex infrastructure. Now it's becoming extremely easy to deploy. You set up a Kubernetes cluster, you turn on Kafka, you add CubeLists onto it, and now suddenly you start writing this glue code, and that complex scenario that you just mentioned, now you can actually, concentrate on it and write it extremely quickly. So you get back to the basis of, what we're all trying to do, which is an extremely quick pace of innovation, writing software, deploying software extremely quickly, and being able to focus on those complex scenarios and doing it relatively easily.
Okay, and as we begin to wrap up, we started off kind of talking about, okay, why isn't there a lot of serverless in production, or how are people using serverless today? And Bitnami, it seems like, is a great example of how you might use serverless. So the little bit of your history is you started a company called Skipbox, and then Skipbox joined Bitnami, largely because it seems like Bitnami is a company that can really make use of the CubeList technology that you were working on at Skipbox. So give a little history for why Skipbox joined Bitnami and what you're doing there now, what Bitnami is, and how CubeList fits into that.
Yeah, so when we started, I discussed a little bit about my background in computational science, and definitely, I saw a point where lots of things is being done in academia, but the industry is definitely pushing extremely hard new technologies and so on. So I decided to leave academia, get in on the industry. I worked on cloud systems, and when Docker came around, containers, we had been using containers for a while. It was not new, but I was very intrigued by the fact that Docker really picked on. So that's why I started writing the Docker cookbook, and that's why recently you heard me talk about do not dismiss, do not dismiss new tech. Otherwise, you may get left behind. So I didn't want to dismiss Docker, and right now I do not want to dismiss serverless. Some people are going to do it naturally, but if you don't dismiss it and you actually try to understand what this is about, you'll realize that this is, a continuous evolution of what we're trying to do. The infrastructure is now boring. Cloud is really good. We have Kubernetes. We know how to do containers. Now let's get back to applications, and let's go back to writing applications, operating them, deploying them. So when we talk about applications, that's where Bitnami comes in. So we had written CubeLists, as part of Skipbox. We wrote additional Kubernetes software like Compose, like a mobile app called Cabin, and different other things. But we started developing CubeLists, late in 2016. And we were talking with Bitnami and focusing on applications. So that's where the two of us, we got together, and we really, hit a nerve. Is that, I saw, as part of Skipbox, I saw that this was all about applications, trying to make them extremely easy to deploy, operate them, and so on. And Bitnami, totally, now has embraced Kubernetes, has the new platform to deploy applications on. So, Bitnami tries to support their users in that entire journey of native installer if you're bare metal, VM if you do VMs, cloud if you use cloud. So Bitnami can package and deliver applications for all those formats. Now Bitnami is a strong contributor to Helm charts, which is like the Kubernetes package manager. And serverless, it's a little bit in the future. There are already some users, but it's an advanced packaging and deployment mechanism. So we want to be well aware of what are people trying to solve and so on. And we think we have a solution here to help the community embrace serverless and be able to build that continuum for applications. Don't leave anybody behind. It's not politics, but don't leave anybody behind. Like, you want to do VM, we can help you, and then we can help you, go through Kubernetes and then potentially up to serverless. So that's where Bitnami and Skipbox came together, and now we're very exciting and pushing further.
All right, Sebastien. Well, it's been great having you on Software Engineering Daily. Thanks for coming on.
Thanks, Jeff.
Artificial intelligence is dramatically evolving the way that our world works. And to make AI easier and faster, we need new kinds of hardware and software, which is why Intel acquired Nirvana Systems and its platform for deep learning. Intel Nirvana is hiring engineers to help develop a full stack for AI, from chip design to software frameworks. Go to softwareengineeringdaily.com/Intel to apply for an opening on the team. To learn more about the company, check out the interviews that I've conducted with its engineers. Those are also available at softwareengineeringdaily.com/Intel. Come build the future with Intel Nirvana. Go to softwareengineeringdaily.com/Intel to apply now.